So in particular, the Tuesday info session that he talked about for sort of learning more advanced Unix, how to improve your efficiency with Unix, is something that you guys could all probably benefit a lot from. So please consider going to that info session. I think it'll help you work faster in the lab. So again, that's Tuesday night, 6 o'clock. They're meeting in the 3rd floor of SOTA, then heading down to the labs. So today is the day when we learn about the central features that make object-oriented languages special and that distinguish them from procedural languages like C and Pascal. And those things are inheritance and in particular something called dynamic method lookup, which we'll learn about this lecture. So to start with inheritance, to give an example to motivate inheritance, in your lab you modified an S-list to create a list that runs a little bit faster when you want to insert something at the end of the list because it maintains a tail pointer that allows you to find the end of the list quickly. So if you have a million items in a list and you want to insert something at the end, instead of having to walk through all million items to find the end of the list like you do in a normal singly linked list, if you add a tail pointer, you find you can just jump to the end of the list and add the new thing right away. Well, we did that by modifying the S-list class, but we could have done that by defining a new class that inherits properties of the S-list class and then adds some new properties of its own. So let's see how that's done. What we're going to do is we start by declaring a class called taillist. And we say, because we don't want to rewrite the whole list code from scratch, instead, we want to inherit as much of it as is useful. So we say that taillist extends slist. And there we're doing inheritance. What do we inherit? Well, among other things, the fields of the slist class. So when I declare my taillist, I don't have to declare the head and the size fields all over again, because they are inherited. So every taillist already has those two fields declared and ready to use. And I just have to add the new fields that I want. Like tail. So a taillist is going to be a lot like an S-list, except that it has this extra tail reference. Plus, I'm going to need to change a few of the methods. I'm going to add more code there, so you might want to leave some blank space in your notes. But first, I want to talk about the code I've written already. Taillist is said to be a subclass of S-list. And just like a parent has a child has a parent. So S-list is said to be the superclass of taillist. And a taillist has three fields, head, size, and tail. Now, a subclass can modify the class that it's inheriting in three different ways. First of all, as I just showed you, it can declare new fields. And second, not surprising, after that, it can also declare new methods. So tail lists can have methods that S-lists do not have. You can call those. The third change, though, is in many ways the most interesting and in some ways powerful one, is that it can override old methods with new implementations. That, for instance, is where we're going to get our performance advantage out of taillist. We're going to make taillist faster by changing a few of the methods so that they use that tail pointer. So number two, adding new methods, is one way of adding new capabilities to a class that it didn't have before. Overriding old methods is also a way to add new capabilities, but it's also a way to improve the efficiency of existing capabilities. All right, so we've done the first one already. Let's try out the third one, since the whole point of having a tail is that we can make insert end really fast. So the way you do that is you just rewrite the insert end method all over again. Right here in the taillist class. Now, taillist is already inheriting an insert end method from slist, but when I declare a new implementation, this new implementation effectively just replaces the old implementation for taillists. And what you write in here is just your solution to lab 3. Goes there. And that's how you override the insert end method. Now, we had to rewrite one method, but we don't have to rewrite all the methods because we're inheriting a bunch of them that just don't have to change at all. Like isEmpty is still the same. Length is still the same. Nth is still the same. ToString is still the same. Those are all just inherited, and we don't need to change them. So we've saved ourselves a lot of work. Instead of having to rewrite the whole class or copy all the code from the old class to the new class, we just inherit it. Makes life a lot simpler. Any questions about this so far? Yes, in the back. The question is, suppose I want to reuse all the code in, say, the old insert end method, and then just add more stuff to it. Can I do that? Yes, I can, and I'll show you how to do that in a minute. But let me take some more questions first. Yes, sir? Yes, that's true. So if a class has a subclass, and that has a subclass, and that has a subclass, then inheritance goes all the way down. The bottom class gets stuff from all the classes above it. Question here. Well, you do have to call you maybe have to call a different constructor. If you want to use a tail list, you have to call the tail list constructor instead of the slist constructor. As for the nodes, the way I've written it right now, slists and tail lists use the same kind of nodes. But I'm going to give you a homework where there are two different classes that use two different kinds of nodes. And when you do that homework, you'll see how to deal with that issue. Yes? Yeah, excellent question. If you have two different methods with the same name but different arguments, different number of arguments, different type of arguments, what happens? Well, for all intents and purposes, you should think of each method that has a different prototype or different arguments as being a different method even if it has the same name. So if I have two different insert end methods and one of them takes one parameter and one of them takes two parameters, think of them just as if they had different names. You can override one and it has no effect on the other. If you want to override both of them, you have to write two new method implementations, one to override each of them. Yes? Can you override constructors? No, you cannot override the constructor. That's the one thing that you can't hijack a call to a particular constructor. A constructor that constructs an S-list always constructs an S-list. And that's a little bit awkward, I admit. And you'll see again in that homework that I was talking about that you'll get next week that, well, not next week, after the first project is done, that next homework will show you how you can deal with that, but it'll also show you why it's a bit awkward to deal with that. Other questions? Yes? Mm-hmm. Uh-huh. Yeah, if you want to go back and use the original method instead of the overriding method, I'm going to show you how to do that in this lecture too. So that's coming soon. Yes? Well, you can always use the default tailless constructor with no parameters. That's how Java provides that for you. But if you don't like the default tailless constructor, then yeah, you have to write your own. The S-list constructors are not going to be helpful. Well, they sort of will be helpful. I'll talk about that in a minute too. All right. Let's see. Okay. Actually, I'll talk about that right now. Let's look at how inheritance works with constructors. Okay, what happens when you construct a tailless, when you call a tailless constructor? When you call a tailless constructor, well, Java executes it. But before it does that, well, there's actually something it does at the very beginning of the tailless constructor, which it calls the superclass constructor. Now, this is automatic. This happens in every tailless constructor you write. When you write a tailless constructor and then you call that constructor, the very beginning of the tailless constructor, that automatically calls the S-list constructor. You can't stop that from happening. You have no choice. And by default, it calls the S-list constructor with no parameters. That you have a choice about. But just to give you the basic example, if I just write any old tailless constructor, I'll keep it simple for now, but it doesn't matter how many parameters the tailless constructor has. Java still automatically calls, at the very beginning of your constructor, the S-list constructor with no parameters, which, of course, sets the size and head fields for you. That's what it's supposed to do. And then you get to take care of any additional tasks that need to be done, like maybe setting up the tail. Now, you might not want the zero parameter constructor. That's what you get by default. And again, it doesn't matter how many parameters there are here in the tailless constructor. It's the zero parameter S-list constructor that gets called by default. And if you want to change that, you have to say so. So the way you can say so let's suppose there's a tailless constructor that takes an int for whatever reason, and you want to pass that int on to the slist constructor. Then the way you do that is you write as the very first line of your constructor super, and then the parameters that you want to pass to the superclass constructor. And then you go ahead and do your other stuff as usual. And just like when you call this method inside a constructor, when you call the super method inside a constructor, it must be the first statement in the constructor. So all the superclass initialization has to happen before you can execute any other code, because the code you execute might be calling methods in the superclass. And Java doesn't want you to allow you to execute superclass methods on an uninitialized superclass object. Any questions about that? Yeah, in the back. Oh, well, I didn't really intend this to be the item. It's just some arbitrary number you're passing in for who knows what reason. Yeah, I'm just picked null here because I'm assuming that we're constructing an empty list when we start. Yes. This right here? This is exactly the same as calling slist x. The only difference is it's not going to construct a new slist because the tail list is an slist, and the tail list has already been constructed at this point. So what this means is we're going to call the code in the slist x constructor, but it's going to affect this tail list object. It's not going to make a new slist object in addition to the tail list object. Yes? If you do what? If you have 10 subclasses, then that's right. It chains all the way down. So, if tail list is a subclass of slist, is a subclass of list, is a subclass of myObjects, is a subclass of object, then yes, the first thing that gets executed is going to be a superclass constructor here, and then a superclass constructor here, and then one here, and then one here, and then one here. Every single class in the hierarchy expects its own constructor to happen. Yes? A superclass constructor can't really... Oh. If a superclass constructor calls a method that's overridden in the subclass, then it will probably execute the subclass version. It'll execute the subclass version of that. Yes? Can a class extend two different classes? No, not in Java. Java does not allow multiple inheritance. So another thing you might want to... Oh, question, yes. Uh-huh. Right. When you call super, it calls that super. You can't directly access the higher ones, but rather this super is going to decide which super to call here. This super is going to decide which super to call here. This super is going to decide which super to call here. And then they can all start executing the rest of their code. Initialize, 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 all the way down. Yes? Super what? Java does not let you do that. Java will not let you skip a step in this chain. Yes? Then if the superclass does not have a zero parameter constructor and you don't include a superline that tells it to call some other constructor, then you get a compile time error. Java will demand that you either fill in a zero parameter constructor or call one of the other constructors with parameters. Okay, anyone else? So that's how chaining works with constructors. You can also invoke overridden methods. Now we're not talking about constructors here. We're talking about all the other methods. And there's ways to invoke them too. And there's reasons like why you would want to do that. For instance, I need to have an insert front method in taillist. For the most part, the insert front method is going to work exactly like the insert front method in slist, with one difference. Sometimes I have to update the tail, because the tail always has to be correct. It always has to point to the last node in the list. But I don't want to rewrite the whole method, because I already have most of the code in the superclass. So let's use that code in the superclass, and then throw in the extra code we need to update the tail correctly. So this, for instance, will affect the insert front method. And so what I'm going to do here is I'm going to call the insert front method in the superclass. And that handles getting the new item inserted into the front of the list. So all that work is done. All I need to do now is update the tail pointer, if necessary. When do I need to update the tail pointer? If I just inserted an item into an empty list, and now I have one item in the list, then I need to update the tail pointer. If I have one item in the list, then the tail and the head are both the same item. If size is greater than 1, that means the tail pointer was already correct, and insert front is not going to change it. So there you go. There's a working insert front method. One difference between this use of super and that use of super is that there is no requirement that this be the first line. In this particular case, it's the first line just because that's how the code worked out. But it does not have to be. Java does not require it to be the first line. So Java's stupid. It has to be the first line rule only applies to constructors. It does not apply to other method calls. And also, you can call superclass methods as often as you want in one method. So it's not like over here, you can only have one superclass constructor call. But you can throw as many of these into your method as you like. Question in the back. Right. That's another thing, is that just because this is insert front doesn't mean I can't call delete back here, or delete tail, or something like that. So I can call any superclass method from here. Other questions? In the front? What if you're returning a value? Well, if you're returning a value, you have to have a return statement in there that says what value you return. Right. So like if insert front were returning some value, and you wanted to return the value that you got from the superclass, you would have to store it here, and then return it here. Unless it's the last line of the method, in which case you can just write return super.insertFront. Yes? Uh-huh. Okay. If you don't override delete back, then you do not have to use super. If you just write delete back, it'll call whichever implementation of delete back is lowest in the hierarchy. Okay. So that's all I have to say about invoking overwritten methods for now. The next topic is a new keyword called protected. Now, when I said that you could have taillist inherit from slist without modifying slist at all, I kind of lied, because you do have to make one change to slist if you wrote it the way we've been learning so far, which is you cannot declare the head and size fields to be private. You see, over here, the taillist class wants to use the size and head field. But size and head are private. They're so private that even taillist can't read them. So we got to fix that, and the right way to do this is you declare them to be protected in slist. Which is really what we should have done in the first place, but we didn't know about the protected keyword until now. So slist, we have to declare those two fields to be protected. And then we have all the usual method definitions here, and everything else is the same as it was before. Now, both fields and methods can be declared protected. And a field or method that is protected is visible to the declaring class and to all its subclasses. So you should think of protected as being a level of protection that is between public and private. And by contrast, private fields aren't even visible to subclasses. Which, in my opinion, means that you probably don't want to use the private keyword very often. Most things you would want to declare protected, because you never know when in the future you will want to extend a class. Question? Well, okay, that's true. slist is no longer by itself able to enforce the invariance. For this to work, you have to trust that the taillist author will also enforce those invariants. So the question is, usually when someone extends a class to a subclass, they're taking on a certain amount of responsibility to make sure that the abstract data type will still work according to the spec. Whether or not that responsibility should be shared with the subclass writer depends a lot on the politics of the company you work for or the project that you're working in. So, I mean, this is a judgment call. When do you make it private? When do you make it protected? We could have arguments all day about that. It's not an easy, there's no cut and dried rule. Yes? Well, I still think that taillist and slist are a lot more trustworthy than all of the other classes in the world that are going to try to use them. I still want to have this barrier that saves people who are using lists in an application from the temptation to actually write code that goes into the data structure and changes it directly instead of going through the usual methods of slist and taillist. So it's a matter of, building walls around pieces of software so that you know how your components are interacting. And I think that it's okay to build the wall around taillist instead of building it around slist and keeping taillist out most of the time. Question over here. Yeah, subclasses of subclasses of subclasses can access protected fields all the way up. Yes? No, a superclass generally cannot access stuff from a subclass that's not public as far as I know. I could be wrong about that, so you might want to look it up just if you really care. So I've kind of already given this away, but subclasses can have subclasses, and subclassing is transitive. So let me give you several factoids. First of all, there is a sort of class hierarchy in Java that looks like a tree branching out down. And at the very top of the class hierarchy is object. You see, object is the superclass of every other class by default. You can't stop it from being a superclass of every other class. Even though you didn't write class slist extends object, well, slist extends object anyway. You have no choice. So all of the traditional classes that you're used to that are predefined in Java, like string or integer, as well as any classes that you define yourself, like let's say we call one worker, those are all subclasses of object. Second of all, like I said, subclasses can have subclasses. And subclassing is transitive. So if proletariat is a subclass of worker, it's also a subclass of object. And if student is a subclass of worker, of proletariat, then student is also a subclass of worker. And student is a subclass of object. All right. Maybe I'll use this board, because now here's where we get to the heart of things. The heart of inheritance is something with the obscure-sounding name dynamic method lookup. Here's where inheritance gets really interesting. Any tail list can masquerade as an S-list. In fact, as far as Java is concerned, every tail list is an S-list. That's important. Put a big box around it. Every tail list is an S-list. Memorize that. Every proletariat is a worker. Every TA is an object, and so forth and so forth. And you guys use them so well. So what this means is that anywhere where Java is expecting an S-list object, you can slip in a tail list object, and Java's happy with that. Java doesn't say, oh, this isn't an S-list. Java says, oh, this is an S-list. I'm happy. It's just like if dog was a subclass of animal, and you asked, give me an animal, and someone gave you a dog, you couldn't complain that that's not an animal, right? Well, every tail list is an S-list. Same thing. So what that means, practically speaking, is that I can write something like S-list S equals new tail list. And that works. I've constructed a tail list and assigned it to an slist variable. And Java's happy because every tail list is an slist. So this is fine. But the reverse is not necessarily true. Not every slist is a tail list. In fact, if I create a tail list variable and try to assign it an slist, well, Java's not happy with that slist at all. It doesn't have a tail. I asked for a dog, and you just gave me a generic animal. It's not good enough. I want a dog. So this gives you a compile time error. Java just says no. Now, coming back to the first line, this is interesting enough that it's going to inspire some new jargon. Memorize these two definitions. The static type of a variable is just the type that you assign when you declare it. But the dynamic type of a variable is the class of the object that the variable references. And as that suggests, the dynamic type can change dynamically every time you do an assignment in your program. So static type means this. The static type of S is slist. Dynamic type is this. After this line executes, the dynamic type of S is tail list because S is pointing at a tail list object. So to figure out the dynamic type of a variable, you actually have to follow the pointer and see what object it's pointing at. Any questions about this so far? In the very back, right? No, you cannot pass an S into a function that expects a tail list. No. But you can pass a tail list into a function that expects an S list. In the very back, orange shirt. We'll see that in a minute. What's the advantage? I'm just about to show you, but I'm not there yet. Yes, sir. Nope, you cannot call tail lists on a static type S list. And I'll show you examples of that momentarily. Yes, sir. Can you cast S to tail list? You can cast it, yes, with an explicit cast. Okay, I think all of these questions are things I'm about to go over, so maybe I'll stop questions and we'll just go over them, and then all right, let me tell you what dynamic method lookup is now that we know what a static type and dynamic type is. When we invoke a method that has more than one implementation, a superclass implementation, and a subclass implementation that overrides it, or for short, when we invoke an overridden method, which one does Java call? Java calls the method for the object's dynamic type regardless of the static type. And that principle is what the word dynamic method lookup means. it's going to take a little bit of playing around with Java and practicing to figure out why this is so interesting and useful. But let me try to give you a little bit of insight into how this works. So let's go back to that first statement that I did. slist s equals new taillist. So we have that picture right there. S is static type slist, but it's pointing at a tail list. And now I do a method call. I type s.insertEnd obj. And this calls the insertEnd method in the taillist class. So it is calling the right method to insert an object at the end of a tail list. And that's good, because that means the tail pointer gets updated. But then I could do it the other way around. I could just say s equals new slist and have a generic slist object that does not have a tail. Now I can do the method call again. And please notice that this line of code is exactly the same as this line of code, yet it does something different. It calls a different slist, or a different insertEnd implementation. And that's a good thing, because this generic slist we just created doesn't have a tail pointer. If we called the wrong insertEnd method and tried to update its tail pointer, it wouldn't have one. But Java knows to call the slist implementation of insertEnd, which does the right thing for a generic slist object. And that's dynamic method lookup. Why does it matter? I'll give you a couple of examples. One is, suppose you have a method that you wrote that sorts an slist using only method calls in the, like insertEnd and insertFront and all that stuff. It doesn't try to manipulate the fields of an slist directly. Then your method now sorts tail lists as well with 0 additional work. It's magic. You wrote a method that does one thing, and now it does another thing on a data structure that you had not even envisioned could exist when you wrote your list sorter. Another example is that maybe you've written a class, let's call it, say, run-length encoding, that uses slists to do its work. And you are accessing these slists, again, using only method calls. One day, you go and you replace the constructor that says, create a new slist in my run-length encoding, with a different constructor that says, construct a new tail list instead. Just like that, your run-length encoding code runs faster, because now you have a faster insertEnd method. And all you did was change one line of code that changes the constructor. So the next thing I'm going to talk about is casting and assigning different types back and forth. If you have any questions that are not about that, this is a good time to ask them. Yeah, in the back, towards the right? Or my right? You, yeah, black shirt. Uh-huh. Can you have one class that extends another class? Wait, a circle or what? No. So you can't have cycles. The inheritance hierarchy I drew looked sort of like a tree branching out. That's the only allowable topology. Other Other questions? Green jacket, yes. Well, I might want to, well, for instance, this might be the list sorter. In the list sorter code, I want S to be the most general kind of list possible so that I can sort every kind of list instead of just one kind of list. Mm-hmm. Exactly. You could make 10 different kinds of lists, and I'll talk about this on Monday. And one list sorter sorts them all. Orange shirt. Uh-huh. Oh, okay. So I am assuming that this code is not in any of the list classes, but this is in some application. So imagine this code is all in, say, a list sorter and not inside the slist class or the tail list class or any other list class. Now, from the list sorter, you cannot say s.super.insertEnd. You do not have the ability to choose which level of the hierarchy will get called. Dynamic method lookup forces one choice on you. It forces you to use the choice that is appropriate for that kind of list. And you have no way of saying, I want to call the slist insertEnd on a tail list in a method that's not in the tail list class. Yes? No. No. Dynamic method forces you to call the right insertEnd for the class that you're using. You don't outside of the list classes, you don't have a choice about which one you call. You just don't. In back, black shirt. Yeah, anything that inherits from slist, if it's implemented right, yes. Well, the list sorter is going to call, if it calls insertEnd, it's going to call taillist.insertEnd automatically. Java makes sure that the right insertEnd method gets called, so the list sorter doesn't have to think about it. The list sorter doesn't have to know anything about the implementation of the list. All it needs to know is the interface, and as long as the list sorter uses the interface correctly, the implementation takes care of itself. Uh-huh. Mm-hmm. You do have to adjust the tail pointer, but this method is going to adjust the tail pointer for you, and the list sorter does not have to know that a tail pointer exists at all. That's the important thing. Right. Right. The list sorter is not allowed to go in and mess with the fields of the list. They're protected. The list sorter can't touch them. And this is the reason why they're protected, is by making them protected, now I've forced the guy who writes the list sorter class to write a list sorter that sorts all lists and not just tail lists. And that's a good thing. I've enforced discipline on that guy, and now that guy's writing better code because of it. Seriously, that's what this is for. That's what this stuff is for. Man, it's after 5. You guys ask good questions, but I'm only 3/4 of the way through the lecture. So I guess I will push this stuff off to the next lecture, and see you guys on Monday.